Suppose we have access to a trained model. How do we deploy it for our end users? Gradio and Hugging Face provide the tools to build a deployable deep learning application. We saw in the previous discussion on PyTorch that deploying a model for general use is still lacking. We may use Jupyter Notebook or Colab, but the interface is still not right for the general public. Gradio and Hugging Face attempt to address this problem by providing a hub for reusable pre-trained models, APIs to build workflow and interface, and a site that people can visit to try and use our deep learning applications. To minimize confusion, we will focus on Gradio as our SDK. In machine learning app development, Gradio and Hugging Face are closely integrated. Basically, Gradio is for building the user interface or what users will interact with. Meanwhile, Hugging Face provides the underlying pipeline to pre-process the input, execute model inference, and post-process the output. Another way to see it is from the perspective of end users. Gradio is the front end, while Hugging Face is the back end. Why Gradio? At the very least, we need an easy-to-access web app that has an intuitive interface to demonstrate our machine learning apps. This is where Gradio comes in. It is focused in providing APIs that we can use to build our machine learning apps. With Gradio, it is easy to demonstrate the functionalities of a deep learning model, like the nature of the input that is accepted and the type of prediction it produces. And once we're done prototyping our deep learning app, we can deploy it on Hugging Face using Spaces. Spaces is a permanent hosting of our machine learning apps that people can easily access. This scheme has been proven useful in business and in collaboration. Clients and end users can get quick access to our products. And why Hugging Face? Hugging Face was initially focused on building natural language processing or NLP applications. With the breakthrough in transformers for NLP, it transitioned into providing tools necessary to access and utilize large language models, or commonly known as LLM. Without available pre-trained large language models, only few companies in the world can benefit from LLMs. For example, training GPT-3 from scratch costs around $5 million. This is beyond the reach of many organizations. In short, Hugging Face is on the mission to democratize the benefits of deep learning by providing the following. A collection of pre-trained models is available in Model Hub, APIs to access and utilize pre-trained models using pipeline, hosting of deep learning apps using Spaces. We will use all of these three services in our examples. To install Hugging Face and Gradio, we run pip install transformers Gradio. Let us build a simple Gradio app. It is like the hello world in Gradio. First, import the required module. Then, define a function that performs a certain action. In this case, it simply concatenates hello, string variable name, and 2 exclamation marks. Lastly, we create an interface with the following parameters. Fn is a function to call upon accepting an input, which is text. The output is also text, which is simply the return value of greet function. With the interface instantiated, launch the app, and it is done. Let us see the app. This is the app in action. We've built a simple web app. with just few lines of code. What if we use Gradio for our pre-trained ResNet 18 as done in our PyTorch and team discussion? It will look something like this. This is far more intuitive than Jupyter Notebook or Google Colab. Let us see how we can build this app using Gradio. Let us build the web app for our pre-trained ResNet 18. This is the modified interface. We assume that we have classify function that accepts input with size 224 by 224. Then the Gradio app shows the top 5 of classes with highest probabilities as returned by classify function. We use the title as shown. For ease of use, we provide 2 sample images that can be found in the file system. A description on what the app is all about is also shown. Finally, we remove the unused flag button. We are launching the app in another browser so that we can easily visualize it. By default, it will be launched within our Jupyter Notebook, which is not easy to see. This is the classify function. By default, the Gradio converts the input image into NumPy. The first step converts the image to tensor. We also rearrange to make it channel first. The set of transforms made of resize, crop, and normalize is done in the green block. Then we add a batch dimension with size 1, since the model input requires it. After the pre-processing of data, the actual model prediction is done within Torch no-grad context. The prediction is then converted to probabilities. Lastly, after conversion to NumPy, the prediction is turned into a dictionary of label as key and probability as value. This is the required format of Gradio output label. Gradio is great. However, we can see from the previous example that there is still a lot of engineering involved before we can use our app. These steps should have been pretty much standard and reusable. Pipeline addresses this problem. Pipeline takes care of the following: input pre-processing. Pipeline does the data type conversion, transforms, reshaping, and so forth. Model inference. Pipeline feeds the model with pre-processed input and retrieves the output prediction. Output post-processing. Pipeline does the data type conversion, reshaping, and produces a presentable result. Let us build an object classifier using pipeline. Apart from the use of pipeline to simplify our code, there are 2 key differences here. First, we will use a 22,000 category image classifier. Second, we will use a more advanced model, which is called BEIT from Microsoft. The model is available on Hugging Face Model Hub. Let us import the required modules. Pipeline is from the Transformers module. We create a pipeline with a specific task called image classification. The model is Microsoft BEIT. Lastly, we launch the Gradio interface, informing it to load the interface using a pipeline. Let us see the new classifier app. This is the new working Gradio image classifier. The model has a much better prediction since it has a much finer granularity compared to the previous example on ResNet 18. We can also see that we just need 2 function calls to build this deep learning application. Hugging Face has thousands of available models in Model Hub that you can use. The models are mostly for NLP, but the collection is improving in the areas of vision and audio. Now that we have a working Gradio app, let us deploy it on a permanent hosting site called Spaces. The 22K image classification that we just created has been made available on Spaces. The link is provided on this slide. Let us visit the site. This is the 22K image classifier, which you can access through our hosted application on Spaces. It is basically the same as the Gradio app that is running on our Jupyter notebook. Let us see the steps to transfer our Gradio app to Spaces. To use Spaces, create an account in Hugging Face, click Spaces, then click Create New Space, enter the name and license. Let us name it Demo Space. Choose Gradio for the SDK. I suggest that while building and testing the app to put it in private mode. When it's already well tested, you can change the access to public. Then click Create Space. The new space will not be usable right away. There are still few steps to do. The entry point is app.py. Click the Files and Versions tab. Click Add File located on the right side. Then add a new file. Name it app.py. Copy the code from our Jupyter notebook to app.py and save. We can see from here that every time we make changes, Spaces will build the app. The process will continue encountering runtime error until we completed the required files. After adding app.py, we upload the assets, basically the two example images. Since Spaces is clueless on the modules that we are using, we have to create a new file called requirements.txt, edit it, and put in the required modules, which are torch and transformers. In this case, I made an error. I can edit the file again by clicking the edit mode. Once the build process is done, the app will be in the running mode. Clicking on the App tab enables us to access our classifier. The functionality is the same as the one in Jupyter Notebook. After testing, change the access mode from private to public under the Settings tab. Your new app is already publicly available. Share the link to your users. Your app will also become searchable under Hugging Face Spaces. Let us build a more practical app, Automatic Speech Recognition or ASR. The app is publicly available on my Spaces. This ASR is easy to build. It also requires two function calls. Pipeline that loads Facebook S2T model and processing calls for the automatic speech recognition task. Then the pipe is loaded using Gradio. Let us use this app. In this demo, we can use a microphone.
Brown fox jumps over the lazy dog.
Or load a speech file.
The association was organized under the most promising auspices.
We can also do the reverse. Given a text, we can convert it into speech. This is called text-to-speech or TTS. In this case, we use another interface method called load that accepts model name. In this case, we use fast speech to build that was trained using LJ speech dataset. Gradio automatically figures out the interface and data processing needed for this task. Let us see the app on Spaces.
Roses are red, violets are blue. The quick brown fox jumps over the lazy dog.
NLP tasks are strongly supported by Hugging Face. One of the tasks is text generation. Let us build a simple app. This text generation app is using OpenAI GPT-2. Let us run this app. Basically, you provide the initial text and the text generation will complete it. We can make the output of a model be the input to another model. This can be done using Gradio Series. For example, the output of the text generation can be the input of a text-to-speech system. In this example, we replace GPT-2 by a much improved language model called GPT-Neo, which is a reproduction of OpenAI's GPT-3. It uses a whopping 2.7 billion parameters. Connecting the output of the text generator to the input of the text-to-speech is done through Gradio Series. Let us see this app in use. The app is like a podcast generator. Prompt it with a topic and it will generate audio about it.
The COVID-19 pandemic started in late 2019 and the first cases were being reported in Canada in December 2019, with the first cases in Canada and the Canadian government adopting some of the containment measures of WHO and the Centers for Disease Control and Prevention.
Thank you for listening. The details of code examples can be found in GitHub.